Hi everyone, in this video we'll look at another example of transformations involving sinusoidal functions. So we're told for the graph to the right, determine the following. It wants us to determine the period, the amplitude, the equation of the axis, the phase shift if we model it using a sine curve, and the phase shift if we model it using a cosine curve. So then it wants us to determine an equation in terms of sine of x and cosine of x. So the first thing that we have to do is it wants us to determine the period. So to figure out the period, remember that the period is the horizontal distance that it takes to complete one full cycle. So the horizontal distance, because each grid space is scaled by 90 degrees, we have at least a 90-degree period. But then we have to think about this. It looks like each of these this would be half of 90 degrees, which is 45 degrees. So we've got 45 degrees plus 90 plus 45 degrees more. So this distance is 180 degrees, which is 45 plus 90 plus 45 is 90 plus 90, which is 180 degrees. So the period is 180 degrees. Next, we have to figure out what the amplitude is. And the amplitude is the distance from the equation of the axis to the maximum. So here we have that the minimum value is -3. So the minimum is equal to -3. The maximum, the max is equal to +1. So the amplitude, should just be half the distance between the max and the min. So that's going to be the maximum minus the minimum divided by 2, which is going to equal to -3 minus, 1 minus -3. Divided by 2, which is equal to 2. If you think about it, that's really just the distance from the equation of the axis to the maximum, or the distance from the equation of the axis to the minimum. It should be the same. So if you could have figured that out just by looking at the graph, I would encourage you to do that. So the amplitude is 2 units. The equation of the axis is just the horizontal line that cuts our function in half. So it's going to be y is equal to, this looks like y is equal to -1. And another way to get that is just to do the maximum plus the minimum divided by 2. So the maximum is 1. 1 plus -3 is -2. Divided by 2 would be -1. And the next thing we're going to try to figure out is what is the phase shift. So if we use a sine function to model this curve, there's going to be a different phase shift than the cosine function. Okay, so let's think about this for a second. And let's see. So if we model this using a sine curve, well, the sine curve would normally start here, and then let's see. So the sine curve normally starts increasing, right? So we would start here, and then that would be one complete cycle of the sine curve. So this could be considered a phase shift to the left 90 degrees. Alternatively, if you find another point, notice that this point here is a phase shift to the right 90 degrees. So we could either use a phase shift to the left by 90 degrees or a phase shift to the right by 90 degrees. So the phase shift is going to be 90 degrees. We'll say 90 degrees to the right, just because that's straightforward. For the cosine function normally starts here. And it normally starts decreasing. So this point is normally, remember that this point is normally here. and then the sine function would gradually decrease. It would start decreasing. So let's say that the origin maps there. For the cosine function, that's a phase shift to the left 45 degrees. So it's a phase shift of negative 45 degrees. Another way to say this is that notice that this point is we could have said that a cycle of the cosine function starts here. In that case, this curve has been shifted to the right by 135 degrees. So it's either a phase shift to the left 45 degrees or a phase shift to the right of 135 degrees. Okay? Now to make things a little bit even, to give you even more options, we could have actually modeled this without a phase shift if we modeled it using the sine curve, and I could have just used a reflection about the x-axis. Okay, so it's just a reflection. So the phase shift or the reflection works. Since I didn't really give you a blank for the or for the reflection here, you're, I guess, stuck with using a phase shift. Okay, so then the next thing that we're asked to do is determine an equation in terms of sine of x and cosine of x. So now we're just going to say that since the period is 180 degrees, our k value, this tells us that our k value is equal to 2. Since the period is equal to 360 degrees divided by k, and if you rearrange this equation, you get k is equal to 360 degrees divided by the period, which is modeled, or which is represented by the variable t. So we would have that k is equal to 360 degrees divided by 180, which is 2. So k has to be 2. The amplitude is just 2, so, and we don't have a reflection here. So since we included a phase shift instead of a reflection, so a is equal to positive 2. The equation of the axis is y is equal to negative 1. So that means that c is equal to negative 1. And notice that here it doesn't matter whether we model this using a cosine function or the sine function. The period, the amplitude, and the equation of the axis is the same no matter what. So the only thing that's different between whether we model it with a sine curve or a cosine curve is the phase shift. So let's write this in terms of the sine of x first. So we've got that y is equal to, the amplitude is 2, so that means our a value is 2. So we have 2 sine of k is 2, times x minus 90 degrees, because we have a phase shift in 90 degrees to the right, minus 1, because that's our c value. Alternatively, if we wanted to use the cosine curve, we could have written y is equal to 2 cosine of k, which is still 2, times x plus 45, or minus 135. So let's just say plus 45 degrees, minus 1. So both of these equations model this curve. Both of these equations are correct. One thing that we should consider is that let's look at the graph of the sine curve and the graph of the cosine curve, because we didn't really talk about this in the last video. So, and I think it's really important. So this is the teal graph here is the graph of y is equal to sine of x, and then the red graph is the graph of y is equal to, is the graph of y is equal to cosine of x. So how are these graphs related? Well, notice that if I shift sine of x to the left by 90 degrees, I'll get cosine of x. So what that should tell us is that sine of x plus 90 degrees Well, that shifts the graph of sine of x to the left 90 degrees. Well, that's equal to cosine of x. Now, similarly, if I shift the graph of cosine of x to the right by 90 degrees, I get the graph of sine of x. So that means that cosine of x minus 90 degrees is equal to sine of x. These are two really useful identities. So let's see how we can, if we didn't want to look at the graph and say, okay, what phase shift here is going to allow us to model this using a sine curve? Like, let's say I had just come up with, let's suppose that I had just come up with y is equal to 2 sine of 2x minus 90 degrees minus 1. And I wanted to model this using a cosine curve without graphing it and without even thinking about the graph. I just wanted to try to do this algebraically, okay? So I can write this as 2 times the sine of 2x minus 180 degrees, where all that I did here was I just distributed this factor of 2 into the brackets, okay? So I can now use this identity. If I want to write sine of x in terms of cosine, a cosine curve, all that I do is I can say that this is using this identity, that this is equivalent to 2 times the cosine of 2x minus 180 degrees minus 90 degrees minus 1. And now I can write this as 2 times the cosine of 2x minus 270 degrees minus 1. And so this curve matches the curve that I'd, or this curve is a way that you can model, or represents one way to model the function that you've got above. In order to figure out what the phase shift of cos of x is, I could just factor this factor of 2 here, and I would get 2 cos of 2 times x minus, let's see, negative 270 divided by 2 is 135. So 135 degrees minus 1. So you can see here that this matches the information that I had come up with before, where I said that, here, let me adjust this for a second, where I said that the phase shift for cos of x would either be negative 45 degrees or 135 degrees. So here I've got a phase shift of, if I use cos of x, it's going to be a phase shift of 135 degrees. And so that would be a horizontal shift of 135 degrees to the right. So this is an algebraic way of coming up with the phase shift and modeling using the sine ratio rather than the cosine ratio.